Hello and welcome back to another episode of Math with So. Today we're going to be doing some similar polygons. So let's get into it. So a similar polygon, the first thing you need to understand is make sure you pick the sides that are actually potentially similar if we are stating if, in fact, these are similar. So this is yes, no. And there are a few ways to do it. The one way I like to do it is to do 10 over this 15. If that is equal to 14, which we'll do in a box, over 21, then that is a true statement. And you can do this two ways. You can either divide 10 over 15, which happens to equal 0.6 repeat, and see if this is equal to 0.6 repeat, which works. The other thing you could do is you could go and take a leaf out of the cross multiplying. If you multiply 10 times 21, and it equals 14 times 15, that is another way to prove that it is, in fact, similar. Okay, so that's two ways to do it. And there's going to be a third way very shortly happening on number 3. On number 3, it's a little bit easier to look at the small parallelogram and look at the bigger parallelogram, and you ask yourself, 5 multiplied by 3 is equal to 15. And as long as 7 multiplies by 3 and equals 21, then we're good to go. And you do need to check to make sure that this, in fact, also has appropriate things going on, like 5 multiplied by 3 is 15 here, and 7 multiplied by 3 is 15 there. So this would, on the surface, appear to be proportional and therefore similar. And at least the sides are similar. However, look at the angles. We have 130 degrees here, and then you can barely see it, but the 40 is actually right there. And that is what breaks this problem, because if this is 130, down here would be 50 degrees. So even though the sides are proportional, the angles are not equal. And in order for any shape to be similar, it has to have the same angles, and these are not the same angles, so this is not similar. Whereas before, I didn't even mention it, but both of these had 90 degrees everywhere. So that is why this one is similar, but number 3 would be not similar, not because of the sides, but because the angles, okay? So let's look at number 4. Number 4 has 100 degrees and then 100 degrees, so the angles check out. You need to check the angles first because that's a creeper. And then 20, I don't know what 20 multiplied by what gets 24, so I'm just going to do smaller over bigger, 20 over 24. And I'm going to see if that is equal to 40 over 48. And I'm just going to do the division test instead of doing the cross multiply thing. If 20, do it on my calculator, 20 divided by 24, you can see it is equal to 0.83. Repeat. Does that equal 40 divided by 48? It does, 0.83 repeat. So this is, in fact, similar, and I would answer yes. Okay? All right. Let's do some on the back side of this paper. The back side of this paper, I imagine we have to find missing sides. It says the polygons each are, in fact, similar. Find the scale factor of the smaller figure to the larger figure. Okay, so we're not finding a missing side, although we could. We might do that on a few. But we need to recognize that this 14 belongs with the 35. And some of that might be difficult, and we're going to do some that are flipped around backwards and stuff. So we got 14 to 35. 14 to 35. This is how you write the scale factor, or at least the ratio of the scale factor. And that you can divide if possible, but they do both divide by 7. And if we divide these both by 7, 14 divided by 7 is 2, and 35 divided by 7 is 5. So the ratio of the smaller to the bigger is 2 to 5. The other thing you could do is 35 divided by 14 and figure out that 35 divided by 14 is 5 divided by 2, which is 2.5. So that means that the scale factor is 2.5, which means that the smaller one is 2.5 times smaller, and the larger one is 2.5 times as big. Okay? That is how you do that. Gonna do a few more. I don't feel like we need to do every problem on this particular worksheet, but there might be some that we get a little thrown off here. For instance, here, this 5 does not belong with the 40, even though they're both kind of on the top. The 40 would belong here. The 5 would belong with either one of these 25s, and the reason why I say either one is because these are both 5, and these are both 25, so it doesn't really matter which one goes with each. So if we do the scale factor, we have 5 small to big, 5 to 25, which if we divide both of them by 5 is 1 to 5. That is the ratio, which means that we have a scale factor of 5. So the smaller one is 5 times smaller, and the bigger one is 5 times as big. All right, let's do, I don't know, let's do one more. Let's look at this one right here. Now this is a little trickier. It's kind of hard to tell where the 7, the 8, the 12, and the 14 go. So let's see if we can confirm it. Okay. Now on surface, I might think, okay, 7 goes to 14. Because 7 and 14, 14 is twice as big. And 8 could go to 12. But look here, 7 is smaller than 8. And 12 is smaller than 14. So let's confirm that 7 belongs with the smaller number and smaller number. So let's see what that is. So let's do 12 divided by 7 and see what that is. And then we'll do 14 divided by 8 and see if it's the same number. If it's the same number, then we can solve this problem. If it's not the same number, we have a dilemma. So let's do 12 divided by 7. 12 divided by 7 is a funky number, 1.71. And 14 divided by 8 is 1.75. So we have an issue here that this problem and the way it's written is very difficult to determine if, in fact, everything is where it is. So let's see if we can visually do this. Now, you should never visually do anything for geometry, but in this particular case, this is all we can do. We're told that they're similar, and we have to pick one of these because it can't be both. Okay? If it is similar, it should be equal in both scenarios. But we do have a missing side here. And this missing side definitely looks like if we flipped this upside down, we would kind of have the triangle look like here, where this would be 7, that would be 8, and this would be the missing side. Notice how 12 looks like the bottom as well. So I don't think we should be using the 12. So the question is, what should we be using if we flip it upside down? We got 14 over here, and then we have this also looks like a slightly longer side, and this looks like a slightly longer side. So this should be the 8, quote unquote, side. And if I had to guess, the 7 belongs with that side over here, which means that neither one of these are potentially correct, and it is going to be 14 divided by 7, which is 2. That is my best guess as the scale factor, is that this is 2 times bigger, and that would make this side over here 16, because 8 times 2 is 16, and this question mark here could be 6, because 6 times 2 would make 12. Okay, so this smaller triangle is half of the bigger triangle, and it's kind of flipped and inverted in a way. All right, that's going to do it for this one. Until next time, my friends, stay positive, and I will see y'all later. Bye.